completely factored. Now, with all factoring, and this is kind of tricky because it doesn't happen very often, so we start to overlook it, and that is step one. Step one should always be take out a GCF. Because there are so many problems where there isn't a GCF, we just get used to like skipping over that step. And if you skip over that step, in a lot of cases, you'll get to a point and you'll be like, well, I don't know what to do with this then. If I don't even know how I would start something like this. And it's probably because you're missing a GCF. Like this one, for example. People might get so into the habit of just using your special rules and so on that they look at that and they're like, well, that's not the difference of perfect squares. And it's not the difference of perfect cubes, so I don't know what to do with it. And what you're probably overlooking is a GCF, which this one obviously has a GCF of what, Morgan? 5 is the number. What's the variable portion of your GCF? Well, this one has x cubed, and this one has x to the first. So what's the smaller of those two numbers? Just x. If you tried taking out 3 of them, this one wouldn't have 3 to give up. You see what I'm saying? Okay, so when I divide 5x cubed by 5x, what do I get, Angie?
5x squared.
Nope, look again. 5x cubed divided by 5x. What's 5 divided by 5? Just x squared, very good. And then negative 45x divided by 5x gives you what, Lucas K?
9.
What?
9.
Minus 9, very good. So now that you've pulled that 5x out, now look at the binomial that's left. Is there something special about that? Okay? Is it well, by special with 2 terms, I mean, is it the difference of perfect cubes, the difference of perfect squares, or the sum of perfect cubes, or none? Difference of perfect squares and difference of perfect squares factor into, what's the vocab word, Jack? B. Starts with a C. They factor into, if you don't know the vocab word, can you just tell me what it factors into? Very good. And those are called, someone help them out, conjugates. Very good. And then always keep your GCF out in front of the whole problem. On the next exercise, or the first one, we're going to kind of go backwards now. Is there a GCF? And what is it? 2x. Pull that out. Good. Good morning. And what are we left with once we pull that out, Natalie? Plus 4. Very good. So the second step when we're kind of bringing all this factoring together is once you pull out your GCF, your strategy that point forward changes based on your number of terms. Like over here we had 2 terms left, so we did a special pattern. So you can either do a special pattern if it's 2 terms. If it's 3 terms, what do we call the strategy there? What do we call when we're factoring trinomials? Oops, I just showed it to you. What do we call this method on the left? Guess and check. Did you see it?
No.
Okay. Or splitting the middle term. Sorry. I was trying to do my best to cover that up. So when you get down to 3 terms, we go back to one of these. Now, obviously, if you're good at guessing and checking and you know your factors well, that's great. Do it that way. Otherwise, split the middle. So for this one, we can put guess, check, or split the middle. And that's if there are 3 terms. And what's the method if there are 4 terms? Starts with a G. Grouping. So if we have 4 terms left once we take out a GCF, we group. So this being 3 terms and being just a plain old x squared, it's fairly easy to factor. Raise your hand if you can tell me what that trinomial is going to factor into. I got 1. Good. Jack Taylor. Very good. X plus 2 and x plus 2. Now, this would be considered factored completely if it was an open response. If it was a multiple choice, I doubt that this is what their final answer would be. How would they clean this up? Sierra?
2x and then x plus 2 squared.
Very good. Anytime you have the same factor twice, they're going to clean that up. Okay, jump to the next exercise. Do we see a GCF there? What do you think, Georgia? No, nothing can be divided out of all 4 terms, so we don't have like an overarching GCF. So then which scenario are we in? 2 terms, 3 terms, or 4 terms? Elena?
4 terms.
4 terms, and so we use grouping. Good. Go ahead and do that on your own. Yeah, and the negative. You had that right. You didn't have the negative. Jason. You know, one more step for grouping. Right? You did GCF once, GCF twice. Some of you have already taken on the completely part. So you finished grouping and you realized something special. Okay, so this isn't actually squared. Right, if you look at the 2 terms, you're taking x plus 3 out in front. Or it doesn't have something in front, but you're taking that out and here's what's left over. You actually only have 1 of those as a GCF that you're pulling out in front and kind of undistribute from both of them. So at the end of all this, and maybe what I just said kind of shed some light on, like Lucas, did that make you do something more when I said that? Okay, there should be 3 factors at the end of this. So when I group the first 2, I take out the x squared, I'm left with x plus 3. I group the second 2, take out the negative 25, I'm left with x plus 3. So then my x plus 3 comes out in front, and here I am. This is only 2 factors, but it's not done completely. So this day is trying to train your mind to get down to where you get and not like, don't pat yourself on the back quite yet and say, oh, that worked out, everything's beautiful. I mean, it sort of is beautiful, but we're not done yet, right? One of those factors is a special binomial on top of it. Do you know which one it is, Haley?
The x squared one.
Right. We have the difference of perfect squares. So this is going to factor further into x plus 5 and x minus 5. So good job. A lot of you did that on your own, which is great. As soon as I made a little comment, some of you were like, oh yeah, I see it, and went further. And so there's actually 3 factors there. Something that we'll talk more about as the year goes on, and this is worth noting now. What is the degree of this polynomial? What's the highest exponent on any of those terms? 3, right? The degree of 3, exactly. So if there's a degree of 3, typically we have 3 factors. Look back at the previous 2. Degree of 3, 3 factors. Degree of 3, 3 factors. The 2x and then the x plus 2 twice. Technically 3 factors. Do you see how that works out? Next one. There is no GCF here. It's 2 terms. Is it the difference of perfect squares, the sum of perfect cubes, or the difference of perfect cubes, or neither? What do you think? Jack, or Luke?
Difference of perfect squares.
Is it the difference, though?
Oh.
This is a trick one, right? It sets you up because it gives you perfect squares, and you immediately see that, but it's not the difference. It's the sum. And the sum of perfect squares is not factorable. And when things aren't factorable, they're called prime. You know that, right? Prime numbers, 7, for example, isn't really factorable into anything other than 1 in itself. So could we factor this into 1 times x squared plus 36? Yes, but nobody does that. Okay, next one. Any GCF, this one is where we kind of up the ante a little bit. Any GCF. What do you think, Owen? What's that? There is no GCF, correct. So you see 4 terms. You think, okay, I'm going to group this. When you group this, what do you see? Versus what are you supposed to be looking for? When you group, what are we supposed to be looking for? We're supposed to be looking for a GCF. There is no GCF here, correct? How many of you see the difference of perfect squares and like want to do something with that? Anyone notice that that's the difference of perfect squares? If you see it now, that's great. But we aren't doing, that's not what grouping's about. So if you see the difference of perfect squares, don't do anything with it if you're in the process of grouping. Because grouping is take out the GCF. If there's, don't write this down, that's why I'm up here. If there is no GCF, you would take out a 1. And then, is there a GCF here? Yes, right? It's 20. So you take out a positive 20 and you're left with 5 plus x. Does grouping work? In other words, do they match? No. Okay? That's because they're not in the right order. So you're going to have to start to get used to, if grouping doesn't work off the bat, we're going to have to play around with our order. And for this particular one, you're just going to have to train your eye over time to see this. The more you get practice with this, the better off it will be. I'm going to reorder this into the x squared first, plus a 20x, plus a 100, minus a 36a squared. And this is going to be grouping of a new kind. Up to this point, 4 terms, we have grouped 2 by 2. In this, we're going to group 3 by 1. Because this trinomial here is a perfect square trinomial. Remember that? Square root of this is x. Square root of this is 10. Double 10x is 20x. So this actually factors into x plus 10 squared. And then we're just going to leave it minus 36a squared. Any questions on that so far? So it's just a little bit of trial and error when it comes to rearranging it so that it's factorable. Now when we're looking at this, you should see something special. Raise your hand if you see what's special about this. Nobody. Oh, Georgia. Okay, we got a few. Haley, what do you see?
Could you take the square root of the negative 36a squared, find, so it would be 6a?
You're on the right track. Who wants to help fine-tune that? Georgia, what were you seeing? Just on this second term, though? Is it the difference of perfect squares? When you look at this, you have to get your mind to see this as there are 2 terms here. We've got our first term and we have our second term. And it's the difference between them, and they're both perfect squares. The square root of this is x plus 10. The square root of that is 6a. So when I do the difference of perfect squares and factor it into conjugates, it's going to be x plus 10 plus 6a and x plus 10 minus 6a, which is definitely new to you. because we're not used to the square roots being a binomial in and of themselves, right? We're used to monomial plus monomial and monomial minus monomial. But this square root happens to be a binomial plus a monomial, and that same binomial minus the monomial, so we have conjugates. So that's pretty good for Elena to see that, and I know she was not fully certain, but she like saw something weird going on, and you know, no one expects you to see that right off the bat, having this be the first time you've ever seen a problem like this. But we have to just train your mind to become familiar with that and to look for that. Okie doke? All right. Now that we did that last one, how do you think we would rearrange this one? Bella.
X squared plus 8x plus 16 minus 25a.
Perfect. And I'm going to kind of separate them so you can see the trinomial. That's a perfect square trinomial. That's going to factor into x plus 4 squared. And that's going to probably take you guys a little bit more time to really see that trinomial and how that factors so quickly. But then minus 25a squared. And again, we have the difference of a perfect square and a perfect square. So that's going to be x plus 4 plus a 5a and x plus 4 minus a 5a. Are we good? Flip to the back. Oh boy. 6 terms. 6 terms can be grouped 3 by 3. Sometimes that will work. Or 2 by 2 by 2. Okay? Don't do this because I want to see if it works. I'm going to first do 3 by 3. What's the GCF here? K squared. Don't write this down until I know it's right. That's what I'm left with. What's the GCF here? 12 doesn't go into 32. I think it's just 4. Negative 4. 8k minus 3k squared. Are they matching? Okay. 3 by 3 doesn't work. 2 by 2 by 2. This is going to work. Take out a k squared. Left with k squared minus 4. Next group of 2. Take out a positive 8. 8k rather. I'm left with k squared minus 4. Last group, take out a 12. I'm left with k squared minus 4. So now I have 3 terms, and how do I know grouping worked? Same thing in parentheses, right? So that k squared minus 4 is going to be pulled out in front. And what's left of each of the 3 terms? Just a k squared on the first, plus an 8k on the second, plus a 12 on the third. Now, you have a binomial. Is that binomial factorable further? Yes. Chris, into what?
K plus 2, K minus 2.
And we have a trinomial. Is that factorable further? Not as obvious. You still want to try, though. Can you come up with 2 numbers that multiply to get 12 and add to get 8? 6 and 2. So if those 2 numbers can be found, we can do this. So to get k squared, it has to be k and k. To get 12, it's 1 and 12, 2 and 6, or 3 and 4. And 2 and 6 are the ones, because 6k and 2k will make 8k, and they're both pluses. And again, there is a more condensed way to write this because k plus 2 happens twice, doesn't it? So you would probably see k plus 2 squared, and then your k minus 2, and then your k plus 6, or some order of all of that. By the way, what was the degree of this polynomial?
4.
4. How many factors did we have?
4.
Okay? That's not always the perfect case, and we'll talk more about that when we see other variations, but that's a good indication of how many factors you should have. So, we didn't get to that one on the bottom, but that's just like the spiral one I talked about. Your homework is from the worksheets. We may pick up with those 2 examples tomorrow. But your homework is right there at the bottom. Any questions? Same worksheet. For the most part, yes. Why don't we do this? Let me change the homework quickly. Just do 65 to 91 and we'll save the other section for tomorrow night. Is that fair? What's that? 65 to 91, just the odds.